Morning, grade 10s. Today we are going to take a look at lesson number 5, which deals with rational exponents part 1. So up until this point, all of the exponents that we've looked at have always been whole number exponents, negative exponents. We have not looked at anything that would be a fraction or a decimal, and that's what we're going to be looking at over the course of today and tomorrow. So the first thing that we're going to do is we're going to look at investigating the meaning of a to the power of 1 over n. So the first question says, complete and evaluate the following. So if I take the square root of 5 and I multiply it by the square root of 5, according to the rules that we established earlier on, I can multiply these two numbers, which gives me 25. The square root of 25 equals 5. Now, if we were to go 5 to the power of 1/2 times 5 to the power of 1/2, my exponent rules say if the bases are the same, I can add my exponents. So I can add 1/2 to 1/2. So if I add two halves together, I get 1 whole. And 5 to the power of 1 equals 5. So given that the square root of 5 times the square root of 5 equals 25, which equals 5, and 5 to the power of 1/2 times 5 to the power of 1/2 also equals 5, what can I conclude about 5 to the power of 1/2? My conclusion is that it must equal the square root of 5. So press pause and try to complete the following for B. Once you're done, press play again, and then follow through my explanation. So this time we deal with cubed roots. The cubed root of 2 times the cubed root of 2 times the cubed root of 2. My product law still works. I can still multiply these together. Gives me the cubed root of 8. And if I calculate out, the cubed root of 8 is equal to 2. If I have 2 to the power of 1/3 times 2 to the power of 1/3 times 2 to the power of 1/3, my power or my product law tells me that I can add the exponents. So if I take 1/3 and I add it to 1/3, gives me 2/3. Add one more 1/3 and I get 1 whole again. So my conclusion that I have to draw from this is that 2 to the power of 1/3 has to be equivalent to the cubed root of 2. So question C says, write these powers in radical form and then evaluate them manually and then verify with the calculator. So again, press pause, try to do these 3 on your own, and then continue playing. So if I look at the square root of 1/2, that's what 25 to the power of 1/2. That was the same as this right here. So I should be able to write that it's the square root of 25, which would be equal to 5. If I have 64 to the power of 1/3, that's the same as taking this cubed root of 64, which is 4. And then the last one, 81 to the power of 1/4, I don't have a 1/4 in the first two, but drawing from the same conclusions, if I put it as a radical, well, the 3 right here, and remember a square root means 2, so this one must be the 4th root of 81. And a number multiplied by itself 4 times to give me 81 is 3. Repeat the process with D. So x to the power of 1/2 would become the square root of x. B to the power of 1/3, the cubed root of b. P to the power of 1/10, the 10th root of p. And so then a to the power of 1 over n would be the nth root of a. So we're going to continue this into our next investigation. Investigating the meaning of a to the power of m over n. So if I take the square root of 5 to the power of 3, and I multiply it by the square root of 5 to the power of 3, what would I get? Well, from above, when we did the square root of 5 times the square root of 5, the final answer ended up just being this base without the square root symbol, because the square root symbol canceled out square and square root. So if I square this square root, meaning I multiply it by itself once, I would get 5 to the power of 3, which is 125. If I take 5 to the power of 3 halves times 5 to the power of 3 halves, it means I add my exponents. So 3 halves plus 3 halves is 6 halves, and 6 halves would be 5 to the power of 3, which is also equal to 125. So what can I conclude or deduce from these two statements is that 5 to the power of 3 halves has to be the same thing as the square root of 5 cubed. Let's look at cubed roots. If I take the cubed root of 2 squared, multiplied by the cubed root of 2 squared, multiplied by the cubed root of 2 squared, if I take the cubed root and I multiply it by itself 3 times, it's going to cancel out that cubed root. So that's going to leave me with just 2 squared, which will equal 4. It's the same thing as what happened up here when I multiplied the cubed root of 2 by itself 3 times. It canceled out the cubed root. If I go 2 to the power of 2/3 times 2 to the power of 2/3 times 2 to the power of 2/3, again, add the exponents. 2/3 and 2/3 is 4/3, plus another 2/3 becomes 6/3, which is 2, and 2 squared is 4. So my conclusion is that 2 to the power of 2/3 has to be the same as this. Has to be the same as the cubed root of 2 squared. So what I'd like you to do is use these two statements and the conclusions to express the following in radical form. So if I have x to the power of 5/3, if I was to put my radical like that, where does the 5 go and where does the 3 go? The 3 becomes the index, the 5 the exponent. So 5 to the power of 4/5 becomes b to the power of 4/5 becomes the 5th root of b to the power of 4. P to the power of 5 halves would become the square root, I don't need to put the 2, of p to the power of 5. And finally, a to the power of m over n would become the nth root of a to the power of m. Let's continue. It says evaluate the following. 8 to the power of 2/3. The 2/3 I can split to be 1/3 times 2. So 8 to the power of 1/3 from the previous examples we've looked at is cubed root of 8. What is the cubed root of 8? It's 2. And 2 squared is 4. I can also write this 2/3 as being 2 times 1/3. So instead of 1/3 times 2, 2 times 1/3. This means take the cubed root of 8 squared. So that's taking the cubed root of 64. So I need to think of a number that I multiply by itself 3 times to give me 64. and I still get 4 as an answer. So the question asks, which of the calculations above is the easier method for evaluating it? Now, depending on your mental math skills, neither method might be easier to calculate, but which one should be easier to calculate is this one. It's easier to find the cubed root of the smaller number than it is to find the cubed root of the larger number. So the calculation that should be easier should be I. So if we look at C, it says write the following in radical form and evaluate manually and then verify with your calculator. So if I wanted to go 64 to the power of 3/2, what I would do is I would do this radical part first. So the radical part would be 64, the square root, because that would become my index, and then I would cube the answer, which is a lot easier than trying to take 64 and raise it to the power of 3 and then try to take the square root of it. So the square root of 64 is 8. And then I have 8 to the power of 3, which is 8 times 8, which is 64. And 64 times 8 gives me 512. If I was to verify this with a calculator, what I would put into my calculator would be 64 power of, and then bracket, 3 divided by 2, and then bracket. And that should give me 512. So now if we look at 4 to the power of 5/2, again, this 2 here is for my radical, and it's squared, so it's just the square root of 4 to the power of 5. Square root of 4 is 2, so I get 2 to the power of 5. 2 times 2 is 4, times 2 is 8, times 2 is 16, times 2 again is 32. And then my final one is 81 to the power of 3/4. So again, if I write this with my radical, 81 goes inside. The 4 becomes my index. So I'm taking the 4th root of 81. So a number multiplied by itself 4 times to give me 81, and that's 3. Take 3 and raise it to the power of 3, so multiply it by itself 3 times, and I get 27. Okay, so I have one more part. Use exponent laws to simplify 8 to the power of 2/3 times 8 to the power of negative 2/3. So my exponent laws state that I can add the exponents. 2/3 plus negative 2/3 would become 0. And 8 to the power of 0 would be 1. So what we're asked to do is to use the result to write 8 to the power of negative 2/3 in a form with a positive exponent. So with a positive exponent, we've already done this. We take the base and we flip it. And there's my positive exponent. So now if I wanted to evaluate this, this would become 1 over the cubed root of 8 squared. Cubed root of 8 is 2. Squared is 4. And again, if you were to check this, you could check this with your calculator. That gives us a rule or a pattern. So there's my rule and my pattern. A to the power of m over n becomes the nth root of a to the power of m. So this m can be in one of two places. It can be right with the base underneath the radical sign, or it can be raised to the power after I take the root. Sometimes it doesn't matter which way you put them in, although when we are evaluating numbers, So after all of these investigations were done, we get a series of rules. So I've highlighted rational exponent rules. So the rational exponent rules say if I take A and I raise it to a rational power, meaning I raise it to a fraction, the denominator becomes the index and the numerator becomes that power. That power of M can be underneath with the base, so it can be under the radical symbol, or it can be after I've taken the nth root. When we're dealing with numbers, it's usually easier to take the nth root of the number and then raise it to the power. This stuff over here, this is set notation. What this means is M has to be an integer. That's the symbol for integers. So M has to be a positive or negative whole number. N has to be a natural number, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, etc. And A cannot be equal to 0 when the value of M is equal to 0, because I can't take 0 and raise it to the power of 0, because anything to the power of 0 equals 1, and it doesn't make sense for 0 to the power of 0 to all of a sudden equal something. If N is even, A has to be a non-negative, because I cannot take the square root, the fourth root, the sixth root, the eighth root, etc. of a negative number. If my rational is negative, I make it positive by moving it into the denominator's place, and then I do the same thing as I did up above. So again, my M can be on the outside, or it can be underneath the radical symbol. So class example number 1 asks you to write the following in radical form and evaluate without the use of a calculator, and then verify with the calculator. So what I would like you to do is I would like you to pause, and I would like you to attempt to do these 6 questions, and then if you get stuck, or after you're done all 6, then you can resume playback and you can see how these questions were done. So if I look at B, 25 to the power of 3 halves, I can write my radical symbol and I can put the 25 underneath. The 2 becomes the index, which I don't need because without the index there, we already know it's a squared to the power of 3. So the square root of 25 is 3. 3 to the power of 3 is 125. If I do the same thing with 1,000, radical symbol, 1,000 goes underneath. The denominator becomes the index, and then it's raised to the power of 4. The cubed root of 1,000 is 10, which raised to the power of 4 becomes 10,000. 27 to the power of negative 2/3 becomes 1 over 27 to the positive 2/3. So this would become 1 over, there's my radical sign, the denominator 3 becomes my index, and then I would square that answer. So the cubed root of 27 is 3, and when I square 3, I get 9. 16 to the power of negative 3/4 would become 1 over 16 to the positive 3/4, which becomes 1 over, again, the radical symbol, 16 goes underneath. Denominator becomes the index, and then I raise it to the power of 3. The fourth root of 16 is 2. 2 cubed is 8. With E, the base is negative, not the exponent, so it's not a 1 over. It just becomes the cubed root of negative 8 and then squared. Cubed root of negative 8 is negative 2. Squared becomes 4. F is a little bit different because the negative is not attached to the 8. So this time when I put it in, I get negative cubed root of 8 squared. So this becomes negative 2 squared, and my final answer becomes negative 4. With G, we have order of operations, so I have to do what's inside the brackets first. Inside the brackets is I take 3 and I square it, which is 9. I take 4 and I square it, which is 16, the sum of which is 25. Take 25 and raise it to the power of 1/2 is the same as the square root of 25, which equals 5. Okay? So class example number 2. Again, what I want you to do is I want you to write the following in radical form and evaluate without using a calculator and then verify with the calculator. So these ones are fractions. They're done a little bit differently, or you can look at them a little bit differently. All I have to do is look at the top and the bottom separately from each other. Don't look at them as one unit. So this 9/4 to the power of 3/2, radical symbol, 9/4. The 2 becomes the index, which means I don't need to put it in. And then I raise it to the power of 3. So this means the square root of 9/4, which is the square root of 9 over the square root of 4. And then that's all raised to the power of 3, which means the power of 3 goes to both parts. 3 to the power of 3, which is 27, and 2 to the power of 3, which is 8. If I have a negative exponent, to make that exponent positive, I take what's inside and I flip it. So my 9/4 becomes 4/9. My 3/2 becomes a positive 3/2. My exponent does not flip, my base flips. So again, radical symbol, 4/9, and then the 2 becomes the index, which means I don't need it, and the 3 becomes the exponent. Square root of 4 is 2, square root of 9 is 3, and then I raise it to the power of 3, and this time I get 8/27. So what I would like you to do right now is try to do question number 5. So spend about 5 minutes doing question number 5, and then you can resume watching the rest of the lesson. So let's continue with class example number 5. Class example number 5 asks you to write the following expressions using radicals. So we're dealing with variable bases. We still apply the same rules as we did with our numbers, only we won't be evaluating anything. So if I have r to the power of 1/3 as a radical, the r goes underneath the radical symbol, the denominator becomes the index, and with the exponent being 1, I don't need to put it anywhere because an exponent of 1 is not going to change anything. If I have s to the power of 4/7, s goes underneath, the 7 becomes the index, and the 4 becomes the exponent. In C, I have a negative exponent, so this becomes 1/t to the positive exponent, which as a radical becomes the 6th root of t. And finally, if I have v to the power of -3/2, to make it positive, it would be 1/v to the 3/2. Remember, it's my base that gets flipped, not the exponent. As a radical becomes 1 over the square root of v, I don't need to put the 2 in there, raised to the power of 3. Class example number 4. I have 64 to the power of 2/3, negative 64 to the power of 2/3, 64 to the power of 3/2, and negative 64 to the power of 3/2. 3 of these can be calculated, 1 cannot. So what I want you to do is take a moment and write all of them as radicals, and then from there tell me which one cannot be calculated. So if we change all of these into radicals, 64 to the power of 2/3 becomes the cubed root of 64 squared. This one would become the cubed root of negative 64 squared. To the power of 3/2 becomes the square root of 64 cubed. And d becomes the square root of negative 64 cubed. So d has no meaning for what reason? Because you can't square root a negative number. You can cube root a negative number, but you cannot square root a negative number. A cube has a volume of 60 cubic meters. Write a power which represents the edge length of the cube. So if I want to find the edge length, and I want to write it as a power, well, to find the length of the side, I would take the cubed root of 60. As a power, that becomes 60 to the power of 1/3. That would be the length. If I want to write the surface area of the cube, the surface area of the cube is 6 of those faces, which would be L squareds. So that's 6 of those 60 to the power of 1/3 squared. So it'd be 6 times 60 to the power of 2/3. So then if I use my calculator to evaluate that, I would get, first of all, the edge length, the 60 to the power of 1/3 equals, what does it equal? 3.9 something meters. So then the surface area would be 6 times that 3.9 squared, which becomes an answer of 92.0 meters squared. So we have 2 more questions left. Question number 6 says, write the number 10 in the following forms. As a power with an exponent of 1/2 and as a power of an exponent 1/3. So this can be a little bit hard to try to determine what the language means. The number 10 means what I want to do is I want to take a number that when I raise it to the power of 1/2, I get 10. That's what the question is asking. So to the power of 1/2, that's a square root. So the square root of what number equals 10? The answer would be 100. So then if I want to write 10 as a power with an exponent of 1/3, it's what number to the power of 1/3 equals 10? And the answer would be 1,000. So now what I'd like you to do is work on the following questions for the remainder of class. 6, A, D, F, and K. Question number 7 and 9. Question 10, parts A and B. And then 11, 12, and 13. And that's today's lesson.